All right, welcome to The Explainer. And today we are going deep. I mean, really deep. Not just underground, but straight up underwater. We're talking about a place beneath the busiest shipping lanes on the entire planet, where an incredible engineering revolution is happening right now in total darkness. So you have this massive continent-sized nation, but it's split apart by these colossal rivers and seas. How do you connect everything without slowing down progress? Well, that's the big question, right? It's the challenge for a whole generation of engineers in China, and their answer is pretty wild. They're not going over these obstacles, they're going straight through them. This is a story about defying nature itself, and honestly, the best way to tell it is through some numbers that are just mind-bending. Just look at this headline for a moment, from Global Times. This is the story behind today's video. How China is building faster high-speed railways using vast underwater tunnels. China is building new high-speed rail lines that dive underneath major waterways, providing fast services without disrupting shipping traffic. With that said, let's go straight to the intro. Okay, let's start with this number. 14 kilometers. To give you some perspective, that's almost the entire length of Manhattan, from tip to tip. Now, I want you to picture that whole distance, but as a high-speed rail line. And it's not just a rail line, it's completely underwater, carved right through the soft, incredibly unstable silt of a riverbed. Wild. Next up, 89 meters. That's how far down this thing goes. Think about a 30-story skyscraper, but instead of going up, it's plunging straight down, underneath the busiest river in all of Asia. You can just imagine the pressure down there. It's immense. And the margin for error? It's literally zero. None. And then you've got the speed. 350 kilometers per hour. We're talking faster than a Formula One car going flat out. And all of this is happening inside a sealed tube buried deep beneath a massive river. It's just incredible to think about. And finally, let's talk about the price tag. $72 billion. And get this, that's just for one section, one of these new steel arteries that the tunnel makes possible. So you see, these aren't just random statistics, they're basically the vital signs of a whole new era in engineering. So the mission here is pretty straightforward. If you want to conquer geography that seems impossible, well, you've got to build some impossible machines. And let me tell you, the machines at the very heart of this revolution are absolute titans. So let's meet one of them. This is Ling Henghao, which means navigator. It weighs a staggering 4,000 tons and is as tall as a 5-story building. This is so much more than just a machine. It's one of the colossal tunnel boring machines, TBMs, that are driving this whole underwater revolution. So let's break down its mission specs. The job, carve a 14-kilometer tunnel. It's got to be wide enough for 2 high-speed trains to pass each other and deep enough to sit 89 meters under the riverbed. And the whole thing has to be so perfectly stable that trains can just blast through it at 350 kilometers an hour. To pull this off, this one machine set a world record. It bored over 11,000 meters in a single, continuous, totally unstoppable push. Just incredible. But here's where it gets really cool. What makes these titans so revolutionary isn't just their size, it's their intelligence. We're not just talking about brute force digging machines here. No, they're basically becoming sentient explorers. Okay, so check out how this works. It has this complex nervous system with over 500 sensors that literally feel the rock and soil around them. And for every single meter it moves forward, it sends 80,000 threads of live data to an AI smart brain. Now, this brain runs what's called a digital twin. It's a perfect virtual copy of the tunnel. This lets it simulate the path ahead and actually predict problems days before they even happen. What you get is a machine that operates almost by itself, with precision down to the millimeter. And this leap in technology, it signals a massive power shift. You gotta remember, back in 1997, China had to import its very first 2 TBMs from Germany, and they paid a fortune for them. By 2006, they'd spent over 10 billion yuan just importing over 100 more. But now, in just a couple of decades, the country has completely flipped the script from being a technology importer to a global powerhouse. And the result of that flip? It's just staggering. Today, Chinese-made TBMs absolutely dominate the global market. We're talking 70%. They're exporting these massive titans to projects in over 40 different countries. It's a huge change. But here's the thing. These incredible machines, they're not just digging random, isolated tunnels. No, each one is a crucial piece in a much bigger puzzle. We're talking about a plan to completely rewire the economic map of the entire country. You see, these tunnels are key links in what's known as the 8 vertical and 8 horizontal high-speed grid. It sounds a bit technical, but the goal is simple. Create the seamless, interconnected web of railways that spans the whole country. And they're aiming for 60,000 kilometers of high-speed rail by 2030. That's a lot of track. So the key takeaway here is that this is about way more than just faster travel times. There was this editorial in China Daily that put it perfectly. It said, the goal is to upgrade the productive DNA of entire regions. I mean, think about that. This is a fundamental rewrite of the nation's economic geography. And the economic kickback from this? It's enormous. Just take the Shanghai-Chongqing-Chengdu corridor, the one this new tunnel is part of. It's expected to create nearly 1.5 trillion yuan in added value for industries all along its 2,000-kilometer path. It's connecting up manufacturing hubs, major labs, and tons of smaller cities that have never been on the high-speed network before. But you know how it goes. With every success, the ambition just gets bigger. And now, engineers are pushing these giant machines into places that are more hostile, more complex than anything they've ever faced before. They're taking on their deepest challenge yet. So say hello to the Pearl River Estuary Tunnel. This one is part of the Shenzhen-Jiangmen Railway, and it just set a new world record for depth, 106 meters below the sea. The conditions down there are so nuts that the engineers have a nickname for it. They call it a geological museum. At that record-breaking depth, the machine has to deal with a constant water pressure of 10.6 bar. To help you picture that, it's like stacking almost 11 kilograms of weight on your fingernail and just leaving it there all the time. The thing is, no one had ever designed a machine to work under that kind of intense force before. The engineers literally had to invent the solutions on the fly. The TBM for this job, Shenzong No. 1, basically had to run a gauntlet of geological nightmares. We're talking punching through 13 different kinds of rock, carefully navigating a fractured fault zone that was almost half a kilometer long, and then grinding through granite that was so hard, about 125 megapascals, which is harder than most high-strength concrete, it needed special diamond-tipped cutters to even make a dent. And it had to do all of that while fighting that crushing sea pressure just meters over its head. So you have these incredible feats, right? The speed under the Yangtze, the record-breaking depth under the Pearl River. Well, it turns out those are all just practice runs. They were warm-ups for the ultimate challenge, a project that if they actually pull it off, will completely redefine the limits of engineering for the entire world. This is the Bohai Strait Tunnel. It's still in the planning stages, but at a proposed 123 kilometers long, it would absolutely dwarf every other underwater tunnel on Earth. I mean, just its underwater section alone, 90 kilometers, that's more than double the length of the Channel Tunnel that connects the UK and France. It's just on another level. And the goal behind it is just as audacious. Right now, it takes about 8 hours to cross the Bohai Sea by ferry. This tunnel would slash that journey down to just 40 minutes by train. What that does is create this perfect, seamless coastal corridor up north, essentially stitching the industrial hubs of northeast China directly to the economic engine of the Yangtze Delta. So all of this brings us to one final big question. Now that we're mastering the technology to literally conquer the depths of our own planet, what's next? What geographical barriers, the ones we've always thought of as permanent, are going to be the next to fall? Because these titans digging beneath the waves, they prove one thing for sure. What used to be an impassable wall is now just the next engineering frontier. Thanks for joining me for this explainer.